It's smooth. So we're on polynomial operations review and preview, page 265. Are we all there? Okay, so this first unit is kind of like one massive unit that we're breaking into two parts. The first part is like multiplying. The second part we call factoring, which is basically, it's not division, but it's kind of the opposite of multiplying in that direction. So we've broken into two parts. Today we're just going to review some pieces. I believe this portion was when you were away last year, like online learning. So this might be, we're going to go really slow through it. And if you have any questions, please ask lots of questions. You might have to say it a little bit louder so we can hear it through the barriers and everything. So are we all on this page? We're good? We know where we're at? Cool. So within your workbooks, I skip sections that I like and cover other sections. Sometimes I'll tell you to like cross off a line and we'll write in there other notes that I feel like are more pertinent than the workbook. So let's first, today we're just talking basically terminology type things. When we're talking about a test, terminology is always like our level 1-2 questions. It's kind of the most basic portion. So a letter in algebra is called a variable. We know this. This should be review. If it's not, you should probably come hang out with me a lot. Expressions have no equal sign. So if we just have some numbers and variables together, like these examples, they're called an expression. Versus as soon as you put an equal sign there, it's an equation. Most of what we're working with in this unit is going to be expressions. So the next few terms might be a little bit, you might forget them a little bit. So we would call a monomial is when there's only one term. So like one set of variables and letters together. So like just a 6 would be a monomial. Just an x is a monomial. 6x is still a monomial. The number with them, so if I have 6x, 6 is our coefficient. They call it your numerical coefficient, but coefficients always are numbers, so I feel like that's super redundant. You could just call it a coefficient. A polynomial is when there's multiple terms. So their examples here would be 6 plus x, makes it a polynomial. A monomial is a type of polynomial, just like a Labrador is a type of dog. So when we say a monomial, it is also a polynomial. Like it's one and the same kind of idea. So when we get more and more specific, a polynomial is one term, monomial, polynomial 2 terms, binomial, trinomial. Anything more than that, we just call it a polynomial. We're not going to ever say like quadnomial or things like that. Generally speaking, in grade 10, we only ever deal with these 3. It's not going to get more complicated than that. When I say deal with, we're going to be like simplifying them or cleaning them up, combining like terms, rarely actually solving for x in grade 10. In grade 11, you solve for x again, just like you've done in grades 7, 8, and 9. Is that okay? Yeah, cool. Okay, so in these ones, we're going to state the type of what it is. There's a couple key pieces that I'm going to cover as well. I didn't highlight it here. So on this line here, I skipped it, my apologies. There's an x in the denominator. So you have to have with polynomials, and I would write this maybe to the side. Have positive exponents. Positive and whole exponents. I feel like that's not written very clearly in these other notes on the sides. So for example, 2x squared is great. We would call that a polynomial. However, if it was like 2x to the power of -1, which do you guys remember that that would be the same as this, 2 over x? You would not describe that as a polynomial. Why? Why do we care about this? We don't really. It's just a way to classify them. You would proceed like mathematically the exact same way with whatever you're doing and solving the same way, but just like, oh, we happen to not call that a polynomial. Really, is it that helpful moving on? Not totally, because it's not super applicable for what you're doing, but we're just learning how you classify things. So, for example, in this first one, my exponents on x and y would be 1s, right? Those are those hidden sneaky 1s. They're both positive. We have some numbers, so this would be a polynomial. but more specifically, we would call it a binomial. The next one, we have an exponent to the power of 1/2. That's not whole, so we just say it's not a polynomial. You could still say that it's a term. It is still an expression, like that's how you would refer to it. But past that, you just wouldn't classify it as anything. On this next one, we have the square root of 7. That's a number, right? Like it's a gross, nasty, ugly number with decimals, but it's still a number. Does anyone know what it is approximately? You know, the square root of 9 is 3. You know, the square root of 4 is 2. So it has to be between 2 and 3, right? So it's going to be like 2.54. Like it's going to be a gross number that goes on and on and on, but it's still just a number. So that's fine. My exponents are both positives. So we would still call this one a polynomial. Specifically, there's 1, 2, 3 pieces to it. So that makes it a trinomial. Okay, this fourth one. We have 1, 2, 3 pieces, but this third piece has an exponent of 0.2. So we would say it's not a polynomial. Seven over a, I could rewrite this one as 7a to the power of -1, which is a negative exponent, so that makes us that again. So again, that's not a polynomial. Okay, so let's turn the page. I'll give you a second. Let's try filling in this table. I'm going to do the first row with you, and then I want you to try the rest. So in the first row, how many variables are there? So there's an x, y, and z. So that means there are 3 different variables. There are 2 terms because a term is like the answer, like when all the letters and numbers are together, being multiplied together, that's classified as a term. So there are 2 terms, which makes it a binomial. Okay, I want you to try this on your own. So I'm going to pause my recording for my online kids, and I want you to try filling it in on your own, and then we'll check our answers together just to see if you are understanding with where we're at. So I'll give you a couple minutes. Okay. Do you feel comfortable enough to share, or do you just want me to say them? Okay, Tim, do the first one.
Well, it's 2a minus 4b plus 7c. There's 3 variables, a, b, and c, and then 3 sections, so that's 3 terms.
Yeah. Right on. Okay, does anyone want to be brave and do the next one? Wyatt, let's hear it.
So I got 2 variables.
Tricky, there's only an x. There's only one.
Oh, so does it mean how many different variables?
Yes,
Okay, well,
yes.
And there's still 3 terms.
Yes. Good. So there's only an x.
So it just means like types of variables.
Yes, totally different variables, different letters. So yes, there's an x. Well, in this case, actually, there's an x squared, and then there's a 3x. But there's only x's. So then we would say there's only one type of variable. That's a good classification there. Hafsa, do you want to do the next one? Good. Good. Okay, this last one looks super scary. Who wants to be brave? Okay, Matt, let's hear it.
There are 2 variables.
Good.
There are 4 terms.
Good.
Which just makes it a polynomial.
Good, beautiful. So if I was to give you a test, which I will, this would be like the perfect level 1-2 question. Can you do that? Okay, not super hard, but that's like your perfect straight up level 1, 2 type of question for this test. So the second like parts of classification is when we're talking about degrees. And there's a few little kind of nuances that are a little odd about degrees that mathematicians have decided on. So the degree of a term is we're looking at the exponents, and it's just how you kind of talk about it. This becomes a lot more relevant next year in grade 11, and I'm going to say that a ton this year, unfortunately. But the degree of an expression or an equation dictates what the graph will look like. And then in grade 11, when you graph things, it's really easy to reference the degree. So we're kind of laying a lot of foundation this year for grade 11 and 12 math. So I'm going to teach you a lot of things. You're going to be like, this is super useless. And this year it is. But next year, when you learn more, you kind of learn the why you're learning it and the application of it. So it's going to be a little bit tricky this year in that way. So the degree of a monomial, really important, is the sum. The sum is what? Addition, subtraction, division, addition. Good. So the sum is an addition problem of the exponents of the variables, only the variables. So if I have 2x to the power 5, that has a degree of 5. There is only one variable. It has an exponent of 5, so we don't have to add anything. This next one is much trickier. So the a has that hidden exponent of a 1 that we don't write down. So I'm going to add all of those exponents together. So I'll add 1 plus 3 plus 2. So we would say that monomial has a degree of 6. That is only for monomials. It's slightly different when we're talking about anything more. Does that make sense there before I go on?
So it's factors without like a power to them, or just the one because it's 3 hundredths.
Yeah, and basically I would say mathematicians are super lazy people, and they're like, why would I write the 1? It's not really needed. It's implied. Exactly. Exactly. When we're talking about a polynomial, it's the degree of the term with the highest degree. So you actually are going to figure out the degree of each piece, and then the biggest one, that's the degree of the polynomial. So let's look at this first one, this first example. This first one here, so 3x squared y squared has a degree of 4, 2 plus 2. The degree of the next one has a degree of 4 because there's only one exponent. The last term is 4 plus 1 because there's that hidden 1 there again, which gives us a total degree of 5. Constants, we would say have a degree of 0 because there's no variable, no exponent. So our overall degree for this polynomial is actually 5 because that's the biggest degree of each of the pieces. Does that make sense? So let's go through, oh, there's one more, sorry. And this is what I just said. So our constant term in this, sorry. So a polynomial has a degree of 0 if there are no variables present. So if it's just numbers, it has a degree of 0. Because those numbers we call constant terms. This is what I wrote briefly up here. So in this polynomial, the same one we just did, the constant term is -2. If there's a subtraction sign, you always include it. Right? Kind of highlights it. We often forget about subtractions and negatives. They're kind of interchangeable, so you always want to highlight that and include that there. This next example that we're going to go through, like the class example here, this is a really good level 2 question. If we made it like a little bit more specific, I could even argue that this type of thing could go up to be a level 3. This type of thing, if we end up doing like remote school or I have kids at home doing a test, they'll do a different version than you. These are the types of questions we'll do more of because you can't just like Google them. You can't just like use PhotoMath or Wolfram or whatever to cheat, right? You have to actually come up with something on your own. So we will probably do more of these types this year because of our circumstances. So a binomial, so we have 2 terms that is a degree of 1. Does anyone know an example of what that could be? I've heard from you 3. Carissa.
6x plus 1.
Good. So that's a binomial. My degree on this x is that hidden 1. Great. Is there lots of different answers for that question?
Yes.
Totally. Okay, let's try B. A trinomial with two variables and a constant term. Does anyone want to try that? Come on, someone else be brave. I know Matt's got this. I know you three got this. Let's hear from someone else. Okay, Matt, go ahead.
3x plus 4y minus 3.
Oops, 4y minus. Right on. So x and y are our two variables. There's three terms there. The constant in this one is -3. What would my degree be for this one? Go ahead, Matt.
1.
1. Good. Right on. This would have a degree of 1. They didn't care, so you could have made whatever degree your heart desired here, but that particular example would have a degree of 1. So C, a monomial with a degree of 6 with a numerical coefficient of 9. Anyone want to try this? Go ahead, Wyatt.
I just said 9x to the power of 6.
Great. 9x to the power of 6. Totally. If you wanted to be like, look at my math skills, we could do 9x squared y to the power of 4. Does that this also meet this question? Right? My degree is still 6. This time I have two variables, but that's cool. I still have the coefficient of 9. A binomial that has a degree of 8 with each term containing two variables. So if I had, let's say, AB minus CD, what do I have to add to this one to make it have a degree of 8? Because I have not met that requirement yet. But what would I change here? Tim?
I guess you could, degree of 8, you could do like a b to the power of 7 minus c.
Like just a 7 right here?
Yes.
Totally, because that A would have a hidden 1. So there's that hidden 1 there, so 1 plus 7 gives us our 8. So the degree now is 8. So there are lots of different ways you could have done that? Totally. Does that make sense? Are we okay? Turn the page. So with this, we generally do it in ascending order or descending order. So we make our exponents go like in a logical format. Generally speaking, we do biggest to smallest with our exponents when we like order the things, order our different terms. So we start with our highest exponent and we work our way down. So for example, the most common one we're going to be working with is trinomials. So we would write it as like x squared plus 3x minus 6. My first term has a degree of 2. 3x would have a degree of 1. Minus 6 has a degree of 0. So degree of 2 is the biggest. I went down to 0. Your workbook is trying to make you think and learn. So once in a while, they'll say in ascending order, which would be smallest to largest, but that's just to make sure we know you understand things. Mathematically, we always want to go biggest to smallest. You'll always see them in that order. So looking at, I'm just going to do, we're not going to follow this. This first example here, if we were to order this in like the proper notation, would be biggest to smallest in degrees. So my biggest degree term here is going to be the 4x cubed. The trick with this one is you have to remember that negative is associated with the 4. So it's really going to be negative 4x to the power of 3. So you can't forget to follow make the negative signs follow with your terms. My next highest degree is x squared. I personally think it's easier to think of it as like 6/5 separate than x squared. That is the same thing as 6x squared over 5 though. Just working with it, I think it's easier to think of it as the fraction is a little bit separate. Then I have my 2x and my minus 7. So I'm just going to write out, so our degrees for these ones, this has the degree of 3, degree of 2, degree of 1, degree of 0 for each of those terms. Is that okay? Cool. Last year, did you guys work with algebra tiles? Yeah. Algebra tiles it's really important that you're always looking at the legend. I think our workbook always restates the legend for you. So in this one, positive is shaded, negative is white. Let's turn the page and actually do some questions with this so you guys can see the application. But the legend should always be posted there for you. If it's not, I will let you like make assumptions as much as you want regarding it. So on this first one, it says use algebra tiles to determine the result of this addition statement. I'm only going to do this one for you guys. So if we have 2x squared plus 1, I'm going to have the two big square tiles. And one little tile. So this first statement represents, we have 2x squares and a positive 1. Then it says we have x squared minus 2x minus 3. So I have another positive x squared tile. I have two negatives, so I'm going to leave them as white. And then I have three little ones. In this example, none of my x squares cancel out. So in total, I drew 3 x squared tiles. I only have my negative 2 x's, but with my ones, some of my ones are going to cancel because I have a positive 1 here and a negative 1 here. So those two cancel, leaving me with negative 2. Is that okay? Cool. When in doubt, you can always draw tiles to help you with this. I'm not going to do the next one because that's just a lot of drawing. Can I slide down? Are you guys okay? Let me know if I'm ever going too fast for you too, please. Okay, so a quick review of like terms and unlike terms. Like terms have the same variable, really important, raised to the same exponent. It has to have that same exponent. So 3a, 7a, a all have an exponent of 1. So we could combine those. But in the next one, it says unlike terms, these guys have different exponents. Yes, they all have the same variable, but that exponent is different, so you cannot combine them. Okay, so let's go through these examples below to help clarify this. So if I'm looking at my a's, I have 3 a's here and negative 3 a's there. So how many a's am I left with? Right on. 0 a's. So I'm going to literally write 0a for you. Actually, I'm going to show 2 steps. You do not have to show this much work. So we have 3a and I take away 3a, so I'm left with 0 a's. Do I have to write anything there then? No, because we never write plus 0. But I'm just trying to show more so you can follow along. Let's look at our b's. I have negative 4 b's, and then I'm adding 3 more positive b's. Negative 4 plus 3 gives me what? Good. Remember with the negative ones, you can just write b. In this case, it's going to be negative b, but that 1 can be a hidden 1. So we could write this as minus b or negative 1b. No, totally personal preference. Whatever you prefer, you have to include that negative, but totally personal preference. Okay, now we're looking at c's. So I have a positive c and I'm taking away 5 c's. So really, there's that hidden 1 there again. So I'm really going 1 minus 5, which gives me a negative 4c. By all means, you guys could go directly to that line. One or the other. You do not have to write both. A question like this, I can see you being able just to work through it in your head and not having to show the extra steps. So you, for me, could go directly to here. If you want to show extra step, awesome. Go right ahead. But that's kind of my minimum steps that you would need to show. This next one is tricky. We're subtracting negatives here. So this is another format that you could write it. Honestly, you don't see this format very often, but it can be written this way. So we're going to show you. So if I have 4x squared and I take away 2x squared, I'm left with 2x squares. That one's not bad. This next one, I have negative 9 and I'm minusing negative 3. So negative 9x minus negative 3. When I subtract a negative, you're adding. We have the same two signs side by side like that. Because the second one is in brackets, this is because those brackets are there. This is like distributive property, really. We're adding 3. So we end up with negative 6x's. That is like the #1 spot where people make mistakes, is forgetting that you're subtracting negatives, which means we're adding. Does that make sense? Is that okay? Cool. The next one, I have 6 minus negative 1. So that same idea again. So 6 minus negative 1 is really saying 6 plus 1, which gives us plus 7. Easy to make a mistake here. If you don't like how they wrote it like this, you could write it like how they wrote it in the first example too. Just rewrite it to whatever your personal preference is. Okay, I want you to try doing, like on the next page, try these two on your own, and then we'll check them together. If you're not done, just keep plugging away and I'll be on the board shortly. So remember, there's so much to keep in mind. I know it can be overwhelming. So a couple of things. Highest degree we always want to put first. So it's not always rewriting it in the order it was provided. So we always want to do that highest degree first. So our highest degree in this first one is our x squares. So I have negative 2x squared and negative 6x squares, which gives us a total of negative 8x squares. I really find it helpful to underline the ones I've done. So that way I know I've like dealt with it. So that way I don't double dip or I don't forget one. So next we're going to deal with just our x's. So I have 4 x's here. And then I have a negative x here. So I'm going 4 minus 1 because there's that hidden 1 there. So I end up with positive 3 x's. Then my last is my constant. So I have 3 here and 5 here. So I end up with plus 8. If you just started with your x's because that was the first term, and then you did your x squares and then your constants, totally fine. But you should rewrite it then in highest degree going to smallest degree. In grade 10, I won't like give you a big fat X if you did it that way. If you did that consistently, like on a whole test, and you had your whole test correct and you did that the whole time through it, I wouldn't give you an 8 though. I would dock you down to a 7, right? Like it matters. Is it the biggest thing? No, the biggest thing is I care is you're combining like terms. That's a small nuance to me. Does that make sense? Okay. How many of you got that one right? The order? Okay, raise your hand if you got it right other than the order. Awesome, that's good. Okay, let's look at this next one. This next one is really tricky. So remember, in order to combine them, we have to have the same exponents. So the same exponent on the A, the same exponent on the B. So on this one, I think it would be easier just to start at the beginning. So are there any other terms that have an A squared and a B? Yes, Charlotte. Good. So 5a squared b, and the first one, so in the total, we're going to have 6a squared b's. Okay, I'm going to reorder mine at the end. I think it's easier on this one to do that way. So the next one, I have a and then b squared. Do I have any other terms that have a single a and a b squared? Matthew. Good, right on. So on this one, I have a -1 at the initially, and then a -7. So in total, I have -8 ab squares. And then I'm just left with this solo guy here. So then I get the plus 4a cubed b. So now I need to check the order of these. So looking at my order of degrees, this first term I've written has a squared with 1b. So this would have a total degree of 3. You do not have to write down this little piece, but I'm just trying to show a little bit better. My next term has a degree of 3. My last term has a degree of 4. So that one should actually be first. So then I would have 4a cubed b. From here, my next two terms have the same degree. Doesn't matter the order you write them then. So you could flip-flop these two around. So I'm just going to keep it in the same order, but it does not matter. That would be your final answer. How many of you got that last one? Disregard the order. Just go combine them correctly. Good. That one was really tricky. Really tricky. Okay, so that's it for like our formal lesson today. The rest of class, which you have like 25 minutes, I want you to do these questions. So with that, make sure like on 9, I said A, B, C, D. Sometimes I'm going to pick really random letters within that because they're specific questions. So these numbers will also be posted on that Google Doc I showed you the last class, but this is what you have to work on for the rest of class. You can chat, you can work with, well, relatively work with a partner. Like it does not need to be silence in here. Okay, at the end of each chapter in your workbook, there are answers. So like on page 274, the answers are there so you can check it. It is not a solution key though. I'll be honest, there has been a couple incorrect ones in here too. So if you're like adamant that you got it right, you very well could be. There are a couple flaws within the workbook.